Hello, everyone. Thank you for coming. So I'm actually an LFM 92, and after having a career as a software entrepreneur and sold my last company, decided to come back to MIT and see how I could give back. And so a few years ago, we set up MIMO, and things are with the express purpose of bringing the power of machine intelligence, so machine learning, AI, into manufacturing and operations, because there are a lot of hurdles to overcome. So that's really what we're working on. And I'm really pleased to have several other of your classmates on to talk about their experiences while they've been here, although you won't really get to know them since they're not all of them. Some of them are headed out, and most of them you will actually get a chance to know. So you've got a combination of graduating and first-year students. So do we want to start with you, Josh, to give a quick intro?
Sure. Hey, everybody. My name is Josh Weisberg. I'm a LGO23 studying civil engineering. And before coming to school, I was working at Boeing in commercial product development. Hand it over to Paolo to go next.
Hey guys, how's it going? I'm Paolo, I'm an LGO23, and I'm in the Operations Research Department. Before coming to the LGO, I worked in management consulting and then at Uber Eats as an operations manager. I think I'll pass it to Michaela.
Yeah, hi everybody. I'm Michaela. I'm an LGO23, so first year, and my engineering is course 6, electrical engineering, computer science. Before coming to Sloan, I first was at Bloomberg as a technical project manager, and then I was at a startup as a software engineer. So that's a little bit about me. I will pass it off to Mike.
Hey everybody, my name is Mike Lenny. I'm an LGO22 studying Aeroastro, and prior to LGO, I worked at Northrop Grumman and really came to LGO to learn more about machine learning and AI. And I've done that, and I'm actually currently working in a part-time capacity, and I will go full-time into this role after I graduate as director of AI for a manufacturing company, that CNC machine shop that does assembly and processing as well for Boeing, Northrop, Lockheed, and a lot of other exciting new customers. So I've really been looking into how I can use some MIMO principles to apply to my internship and how we can improve the efficiency of my company. And it's been quite interesting, so I'm happy to talk about that. And I think I'll get a chance to speak to that in a little bit more detail in a bit.
Yes, I'm going to keep my remarks brief to let the students talk about their experiences. And as an example, what Michael Lunny is doing is exactly the type of research that we want to do. I think, what you've done with finger lines is super creative. And I don't know how much time he's really going to have to talk about the detail, but there is, you'll be able to read his thesis and then the paper that you wrote on the other competition. But it really is taking algorithms that we already know and applying them creatively into manufacturing and operations, and overcoming a lot of the challenges that that manufacturers really have in terms of small data, and class imbalance types of things. So let me kick this off. Can just give me a verbal if everyone can see the application. Looks like they can. So it's myself and 2 faculty. So you'll recognize these names, or you will come to recognize them. So Professor Bonning from EECS and Professor Levy from the Sloan School. And one of our big goals is, how do we get the shortest path from impact, or from data to impact? How do we help manufacturing companies with that? And the structure of the program is, it really is a research and educational program. The goal is to increase industrial competitiveness by deploying machine intelligence. And so we have 3 components: field-based PhD level research in manufacturing and operations, and I'll give you a couple examples of that. Education, so we run a deep learning workshop and a symposium that Paolo will talk about. And then lastly, collaboration. So the symposium and events like the Student Research Forum, which Michaela will talk about, are designed to, in that particular case, have you interact with PhD students, both in the engineering program and in the business school or the Sloan School, to discuss machine learning related topics. And the goal is then, as you go out on your internships and onto your careers, that you will help with this transformation. And also, obviously, we're educating industry as well to help make it easier to pull these projects into industry. Right now, our research really focuses in two areas: intelligent manufacturing systems and intelligent supply chain. If we were to look at intelligent manufacturing systems, it's kind of these broad categories where we're looking at continuous and unit processing, monitoring, control, mixed data types, digital twins. We do a lot of anomaly detection and classification, and predictive maintenance. And then, how do we bring the human back into the loop for these kinds of projects? I'll give you one example, or a couple examples here. This one's analog devices. And what we're doing there, they're a manufacturer of semiconductors. It's high mix, low volume comparatively, and they have very small lot sizes and very high yield. But when they do have a problem, it's a big problem. It's very costly. And what happens is the way semiconductors are made is you start with a silicon wafer, and then you either etch away or you deposit onto it or implant ions. So this is an ion implantation process. And our goal was to determine when they're making bad parts, when they don't have any bad parts to learn from. And the processes are far more complex than statistical process control, which assumes a Gaussian distribution, which this is not. So really, it started as it's now a 3-year ongoing research project, and we're going to extend it for another 2 years. So a really interesting problem there. I won't get into the Bayesian optimization that we're currently using, but suffice to say, there's some really cool stuff being done there in terms of how we train and learn. And then we're in kind of a deployment phase. So what we're looking now is at transfer learning and concept drift. So how do we take a trained model and transfer it from one process to the next, one machine to the next? There's slight differences and you need to do some relearning. And then these processes inherently drift over time. The machines, every 6 months, they take them apart and clean them. So they change slightly over that 6-month time, but they can still make good parts. So interesting problems there. This is a project we're doing with a partner company, Nissan. So they make engines. It's a very complex engine. And for those of you who are gearheads, it's called a variable compression ratio engine. What happens in that particular project is they use a harmonic drive to dynamically move the crankshaft up and down in the engine to change the compression ratio. So it makes a little 4-bar linkage at the bottom. It's a hugely, very sensitive linkage operating under a tremendous amount of vibration and pressure. And the engine can't fail. And they make one, I can't tell you the exact amount of time, but less than a minute, these engines come off the line. And so they measure almost 10,000 different variables during the course of the production process, everything from incoming quality to process data. So, the actual torque of a nut driver, the full torque curve, pressure fitting bearings in, the full pressure curve. They have all that kind of data, then test data. And the challenge is they've got engines that pass every test, but they know they might fail in the future. So our job is to set up a virtual quality gate from these thousands of pieces of data and determine which correlations ultimately lead to a failure. So it's a really fun project. And that one will probably continue on as well because we're getting great early results. I won't get into how that works, but essentially we're training a regressor, and then we're looking at what the outcome of specific tests and different values, and then deciding, oh, this might pass or fail. Another project we're kicking off is with it's the Saline Water Conversion Corporation. So this is really a large project for us. We have 5 faculty working on this and 5 PhD students over the next 2 years. What this chart is showing you is that Saudi Arabia is the #1 OpEx company for water desalination in the world, and number 2 is actually the USA right behind it. So little known fact, the USA spends a tremendous amount of resource desalinizing water, and given droughts, that's only going to get worse. So we've got these faculty that are working on it out of EECS and mechanical engineering. I won't really get into the details, but what we're trying to do is SWIC is the largest in the world and the best in the world right now. They're the most efficient on a kilowatt hour per cubic meter basis. They've even hired Guinness Book of World Records to validate it. And they realize they've come to the end of what they can do by paying consultants tens of millions of dollars and billions of dollars to manufacturers. So they've come to MIT and say, can you layer machine learning across our unit processes, our plant and system operation, and our overall configuration, and see where we can save even 1%? Because that's a huge impact to them at the scale that they operate. So those are the more techie research projects. We just published jointly with McKinsey a study on how machine intelligence is being used in manufacturing and operations. And that was published in Harvard Business Review. So we're really excited about that. We've got a tremendous amount of interest coming in from that. This is a longitudinal study that you guys can get involved in next year. So by longitudinal, I mean year over year. So we can see the changes in how machine intelligence is used in manufacturing and operations. I will skip over all of this. We decided to use the dogs eat the dog food. So we used k-means clustering to do a massive clustering analysis as part of our research. Some really interesting results. We developed an implementation playbook that's an output for every student. And, a research assistant wrote this. It's all written in Python to automatically generate these things. So anybody who wants to pick this up next year I'm looking for people who are interested in this project and Python programmers, so we can carry this forward because we've got a lot more we want to do with the research. Here's where it was published in Harvard Business Review. It was also covered on McKinsey.com. MIT News has picked it up. Fortune, I don't have it on here yet. Fortune is on it, and we've got a nice podcast. And these articles you can find at mimo.mit.edu. So that's an area where you could get involved. We run a deep learning workshop. This is last year's workshop sponsored by NVIDIA. It's a 1-day workshop. I was focused on deep learning because I felt that certainly you'll see in your curricula that we don't get to spend that much time on deep learning. So this is something where you can attend and learn in a 1-day session. So NVIDIA sponsored last year, and then Google TensorFlow sponsored this year. It's really, really interesting. You can actually watch that full video on the website, and the slides are available. So that's an area you could get involved in 2 ways. One is attend, obviously, the deep learning workshop. We try to do it at a time. We do it at a time when you can attend, and also be on the committee. We have a candidate for next year, but someone needs to take that over because the Samesh, the student that's running it, is going to be graduating. So he won't be able to run it next year. So we're definitely looking for someone to pick that up that's really interested in deep learning and wants to work with leaders. Michaela will talk a little bit more about the Student Research Forum. So I won't go into that, but that is an area where you can come and two things, once again, be on the committee with someone like Michaela or attend these events every week. They're in person and they're collaborative. Paolo will talk about our symposium coming up on May the 4th, Star Wars Day, so you can all remember it. I don't know who's in town, but I've got some really interesting things going on there. The most interesting, which is Cognex is a huge machine learning, not machine learning, vision company. So for example, Amazon is their largest customers. You eventually will go to an Amazon fulfillment center and you'll see little yellow boxes like this all over the place. And they've got a nice machine learning layer on top of it. So they're sponsoring a poster competition this year on May the 4th. And then this is just some of the faculty. There's more. I'm going to stop right there and hand it off to, well, why don't we talk about the symposium, Paolo, and what you're doing?
Sure, more than happy to.
Already kind of talking about it.
Oh, okay. Okay. Can you guys hear me?
Yes.
Just give me 1 second. There you go. All right. So yeah, I think I've met a few of you guys. I'm finally excited to actually start speaking about the cool things that we are doing here at the program. So in particular, let me share my screen. We are planning this symposium, right? And the idea of this symposium is that there are a bunch of leaders out in the industry that are not as technologically adept as we have been trained for, or they really want to learn how they implement, use AI in their businesses. But like they don't know exactly where to start, right? So we're inviting them over for an all-day in-person event, and there are like 3 main components of the event. There are going to be a lot of talks from both faculty and external speakers of how other companies have successfully implemented AI and data in their day-to-day operations and how have they succeeded at this. So we have speakers from Meta, we have speakers from Shopify, we have speakers from Drapers, and we have a great deal of speakers. But it's also an opportunity for this industry leaders to actually get a chance to meet, interact, and like see what's the cutting edge on research that's been doing on this field, right? So these attendees they're going to have the opportunity to chat, to see the research, to interact with the students. So it's like a very inclusive event, like a face-to-face with like a lot of interactions between students, industry, and like all the attendees. Let me share my screen with you so that I can show you a little bit more what are we thinking. So the title is Operationalizing Your AI Strategy. We are still refining the marketing, but this is the title that we came up with. And we are going to cover 2 main topics here. So it's going to be mostly technical readiness. So what do companies need in terms of technical capabilities to implement AI on their businesses? And the second one is organizational readiness. So as a lot of you guys might know, it is not very easy to change from a traditional manufacturing operation to a data-driven, more like tech startup software company in the manufacturing and operations space. So there's a big organizational component and cultural component. So we want to teach and we want to empower these leaders to do these transformations, right, in their companies. I can send you a link a little bit later, but these are some of the confirmed speakers that we have. We have professors, we have such as Rama, we have the director of operations research from Shopify, people from Draper, and all of them are like senior directors, right? That are want to share what they know and how did they carry out these transformations in their businesses. And we have the McKinsey partner that helped Bruce with the study that he mentioned beforehand, right? Again, this has been sponsored by, we are a whole team of LGOs. We are actually missing a few people here, but like this is also a really good chance for you guys to work first, to take on a leadership role for planning a conference, which is extremely different from other leadership roles that I've had. It definitely comes with a lot of challenges and a lot of I don't want to say problems, but like a lot of challenges in general that you need to solve, right? Again, this is also something that this is the first time that we're doing this, yet we have been able to raise quite a lot of money from our sponsors to actually help us carry out this conference, to give out the awards, and you know, we need to pay for the lunch and ensure that the conference is a success for everyone, right? So we're very excited. We currently have a limited number of seats, but if any one of you guys is interested in attending and you're going to be in Boston around on that date on May the 4th, we would love to have you. Send me out an email and we can happily send you the registration link. I think it's a terrific way for you guys to start getting involved with the community, and yeah, we would just love to host you. Any questions, or there's going to be a...
Yeah, why don't we do all the questions at the end? Michaela, I mentioned the research forum, so maybe you should go next. Good segue into that. And then we'll go with Josh with the implementation model. I did not talk about that. And then we can let Michael Lunny back clean up. And then we'll go to questions.
Sounds great. Yeah, so Bruce mentioned the Student Research Forum. So we meet pretty much every week on Thursdays, 12 to 1 o'clock. If any of you are on campus, you should certainly come out. Our next event is going to be this Thursday. And so basically what this group is a combination of LGOs, and also this is kind of our main connection to the PhD students that are working on machine intelligence type of research. So that's what this Thursday is going to be about, is Josh Wild and Evan Yao. They're both in RETCEF's under the Operations Research Center. They're both PhD students there, and they're going to be talking about some of their applied work within Amgen. And I think that's one of the really exciting things about the research forum in general, is that it's not just theoretical research, it's the application of that within industry environments. So it's really great to just hear the different research, the different types of work that people around the MIT community, particularly in the engineering departments, are working on. It's also, like Mike actually presented last time, and it was really great to hear about his internship work, because it's super applicable to MIMO's mission. So if you have any questions or want to get involved, let me know. And you can also look at this website, see what's upcoming. So the person on April 28th, I know it's a week after adMIT weekend, but if you're still around, this is one of the, this is somebody from Cognex, who's the sponsor of the symposium, and he's going to be talking about his company's work. So that'll be great. And you can see Mike's here, and we have some recordings as well. Not every one of them is recorded, because some of these are proprietary information from the companies themselves. So you won't see every single one that has a recording, but many of them do. So do check that out if you want. It's on the MIMO website at the Student Research Forum.
Thank you. Excellent. Josh?
All right, can everybody hear me? Cool.
Yes.
Thumbs up. Hopefully they're done testing my fire alarm here. Let me know when you can see the PowerPoint presentation.
Yes.
Okay, awesome. All right, so yeah, I'm going to share a little bit about the MIMO implementation model, like Bruce mentioned. My goal of sharing this today is to hopefully make everybody excited about MIMO, of course, interested in both using the implementation model as an LGO student, and hopefully interested in contributing to it. And so I'll kind of explain what that looks like. Okay, so first of all, so what is the implementation model? So it's a guide for the implementation of machine learning in industry. makes sense with what Bruce talks about, that, that's what we're trying to do on a high level. It's focused, of course, on the challenges of manufacturing and operations. It does both a baseline understanding of implementing machine learning for anyone who hasn't done it before. And it's not necessarily, what you learn in a machine learning class at MIT. We have tons of machine learning AI classes at MIT, lots of different options for you to take in your coursework. This is more focused on, okay, once you know the technical skills, you can write some code, you can understand how to work with data. How do you go do it in the real world, where there are different challenges that you don't necessarily talk about in your classes? In some classes you do, and in some there's much more to be, more work to be done for how to actually go put it into practice. And then there's also the deep dive into like the persistent challenges of implementation. So there's things that, as I've been at MIT and I've been talking to people who worked in various industries and in various different roles, we come back to a lot of the same challenges. And so how do we solve those or mitigate them at least? And we make recommendations to both the individual, like yourselves, and then also to enterprise leadership. What can a VP at a company think about in terms of setting the right data strategy? And those are the kinds of things we're going to be talking about at the symposium that Paulo mentioned earlier. So where does all this come from? It's sourced from the knowledge of the MIT community. So that's students, partners, alumni, and faculty. Lots of knowledge there, obviously. And we're just trying to work together, get it out and get it written down. And the main goal, hopefully this is helpful, this implementation model, which just to explain, what does it actually look like? Right now it's a 15-page document with all sorts of text and diagrams and comments and discussion threads, targeted to, or hopefully available to anyone who can benefit, but targeted to LGO students who are going on internship, who are going to be doing machine learning implementations and could hopefully benefit from a guide created by their MIT community. So how do we, actually go about getting that knowledge of MIT? It looks like discussions with, for in my case, LGO22s, the year before me as an LGO23. So, I talked to Mike last fall about his project and learned about some of the challenges he faced and how he was overcoming them. Reviews with alumni. One of the coolest things that I like about working on this is one-on-one brainstorms with MIT faculty. I sit down with professors and I say, hey, here's this problem that I've found out about from lots of my peers. I see a common theme. How do we solve this? And then we brainstorm together. We do story time. Paulo and I have spent many lunches sharing the problems that we faced in our prior jobs, and what was different. Him at Uber Eats, me at Boeing. Very different approach to data. What can we learn from each other? And then different articles and publications from the community. And there's tons of talks across Sloan, from the Analytics Club to analytics seminar classes to all different sorts of events where we talk about analytics and we can learn from speakers from around the world. So this is just a brief summary of like kind of how the model flows, the process of how do you implement machine learning. You identify, you plan a project, you do the data and engineering and analytics, you do the machine learning itself, you figure out how to scale it up, get it into production, and then you put it actually into the workflow, and do the change management and monitor and maintenance over time. So those are kind of like table of contents of the model, just to give you more of an idea. And like I said, includes things like discussion notes, proposed solutions and advice, examples. So we collect stories, we get them written down to help illustrate the things that others have faced in the past, and then just definitions and terminology to hopefully help facilitate the use of machine learning. So where do we go from here? Yeah.
Love it. I love it. Sorry.
No, yeah. So we want to work together as an LGO class. So we've formed a cohort, and what is the purpose of the LGO analytics cohort is to support each other. So that means, well, we don't really know what we're going to define what it means in the next few weeks. It could be meetings with the whole group of the 35 or so of us that are working in related positions this summer, or just interested in analytics. It could mean a network to say, hey, I have this problem, who's worked on something like this before, to share success stories, challenges, whatever it might be, to help as we embark on our internships and deal with the challenges of machine learning implementations. And then that, of course, helps us learn. So, I might, if Paulo asks Michaela for help, and Michaela says, hey, I've solved that problem before, let me help you. And then I'm going to listen in and I'm going to learn from Michaela too. And we're going to maximize our learning. And then what we're going to do most importantly is we're going to write it all down. We're going to build a body of knowledge via the implementation model. The implementation model is our vehicle for capturing all that we're learning through this cohort and building it over time to your class, to the next class after that, and to future classes. So we have this great guide that can help anyone who is interested implement in practice. So yeah, that's kind of all I had prepared to talk about. I'm happy to answer any questions later. And
Thank you. Excellent progress.
Of my machine learning homework, actually.
There you go. Yes. Thank you
Awesome.
for squeezing this in time. And Michael?
Yeah, so I guess I'll take the floor now. And a quick comment as I get started here. I think it's incredible to see kind of how everything got operationalized with MIMO over the couple of years. I really came in wide-eyed and wanted to get involved, and it's nice to see the level of engagement is increasing. And so I mention that because I think if you're even somewhat interested in any of the topics that are being talked about today, get involved early. Some of you have decided that you're going to go to LGO, great decision. Some of you are still thinking about it. Hopefully if you're into what MIMO has to offer, it can help sway you in the right direction. But certainly get involved early if you can. And also just want to say congratulations on getting accepted. It's a big milestone. And when I was in your shoes, I put down a set of goals of things I wanted to accomplish at LGO. And I mentioned before that a big part of that for me was trying to figure out what was going on with AI and machine learning. If you want to go back to business school, especially if you want to go to LGO, you most likely want to be in some kind of executive position, maybe at a tech company in the future, if you're not already. And a big part of that is utilizing data in the right way. And it's also going into different industries that are traditionally not very good at utilizing data. And I think MIMO offers a really interesting way to figure out how we can apply those intense data skill sets and be really effective managers in the midst of a revolution where everybody is starting to use data. So keep that in mind as you're going through LGO. And for me, that's why the first thing I did was I took an AI class. During the summer, you take a class that introduces you to some of the topics of machine learning. And that really blew my mind and I wanted more. And so you're going to do an internship depending on the company that you get matched up with. Hopefully if you express your interest, you'll be able to get an internship that aligns with some kind of MIMO type project. And for me, I worked at a private equity firm, but they owned a small manufacturing company that was trying to understand what they could do with data analytics, AI, machine learning. And this company is a CNC machine shop, for lack of a better term. And if you're not familiar with that, you're basically cutting metal, making chips fly on parts. And we make those metallic parts, we assemble them into larger assemblies, and we sell them to OEMs, Boeing, Lockheed, Northrop, and some others that I mentioned before. But it can be quite an inefficient process because a big part of that is telling the machine how it needs to cut that metal. And that process of creating the machine program is what it's called, takes quite some time. So it can take a week or it could take up to 6 months. If you see some of the parts that we make, they're quite complex. So we typically err on the side of needing to spend a lot of time in the programming process. And so what I wanted to do was look into ways that we can use AI machine learning to reduce that time. And what's interesting about it is that it's a completely, well, I shouldn't say that nobody's looking into it. People have been looking into it for a couple of decades, but the approach I took was quite unique, respective to everything that I've seen in the literature and conversations I've had with Bruce and other people that have looked into the problem in the past. So it was nice and refreshing to take a look into that and kind of apply everything I learned in class into this problem. And I definitely did apply the things that I learned in class. So taking the AI class that I took in the first fall, and then taking the machine learning class that I took in the semester after that, these were concepts that stuck with me as I was thinking about how I can formulate my thesis and actually try to provide value to the manufacturing company. And I'll save everybody the technical details of kind of how I built everything. I'm happy to talk about that offline if you're curious. I assume we'll share some contact information at the end. We'll figure out a way to keep in touch. But one other thing I want to mention is, in addition to the internship work, I actually, as I said, I took a class in machine learning in the spring of my first year, and you do a project in that class. And for that project, I built this algorithm that I called finger lines, which is what Bruce mentioned earlier. And it's a method to recognize features in CAD files. If you're not familiar with the term CAD, it's like a 3D model that you would see. And that problem is a really important backbone to the industry that I'm working in with CNC machining for a lot of reasons. I won't go into them now, but it was a really refreshing look into, how can I take a CAD file and use my own unique way of analyzing the data and trying to predict what the features are in that file. And that was a lot of fun. So I got to write a paper. I think with a little bit more work, it's actually something I could publish, but it certainly was a good segue into my internship when I was kind of extending on the feature recognition problem and going into how we apply that into manufacturing. So I think it's great what MIMO is doing, getting more people involved, to see it more operationalized. And as I said at the beginning, get involved early. I think, the concepts that MIMO is offering are really groundbreaking. And it's really a good idea if each of us understands it to some extent, because we're going to be the people that are in charge of making decisions for very influential companies. And we need to do so with a mind of how we analyze data and improve manufacturing operations. So yeah, I guess that's the end of my little spiel here. I'm happy to answer any questions if anybody's curious about any of the technical details or kind of the way I was thinking about MIMO as I was going through the 2 years that I had here.
Excellent. Thank you, Michael. That was awesome. I couldn't have asked for a better testimonial there.